Good afternoon or good day, students. Welcome to Cognitive Psychology. This is topic 7. Today we'll be covering long-term memory, encoding, retrieval, and consolidation. Okay, there's a possibility that this lecture will be in 2 parts, so this will be part 1. Now, last week we noted that there's some evidence to suggest distinctions between long-term memory and short-term memory. And today we're going to look at specifically long-term memory with regards to encoding, retrieval, and consolidation. And throughout the lectures before, when we talked about memory, we did briefly go over what is encoding, right? Which is the storing of information, and retrieval, right? The concept of consolidation may be new to us. So first, we're going to look at encoding. And encoding simply refers to the process used to get information into long-term memory. Now, we have different definitions here that we need to note, right? So the process of getting information into long-term memory is essentially what coding is. Remembering involves accessing some of the information that you have encoded and transferring it from long-term memory into working memory. As we discussed before, when we talked about working memory, we know that it's a combination of taking information from sensory memory, right, processing that information, and oftentimes to make sense of that information that we receive, we will retrieve information from long-term memory and then put that together to have a accurate perception, or at least as much as possible, accurate perception of what is happening or what is before us. Now, the process of transferring information from long-term memory to working memory is called retrieval. So it's a two-way process, right? So encoding, again, is acquiring information and transforming it into memory. So that's putting information into long-term memory. Whereas retrieval is taking that information from long-term memory and bringing it to working memory. Now, there are several ways to get information into long-term memory, and some methods will be more effective than others, right? For example, we have, if you receive a phone number, you can hold that phone number into memory by repeating it over and over. And we talked about this in the example last week where the person was ordering or wanted to order a pizza. They would have looked up the phone number online, and in looking up the number, they got the number. And to remember it, to take the time to make the call, they would have repeated over and over. Now, if you do this without considering the meaning or making connections with other information, you're actually engaging in maintenance rehearsal. So typically, this type of rehearsal results in poor memory because you're just repeating it over and over. So you don't necessarily remember the number when you want to call it again. But if instead of just mindlessly repeating the phone number over and over, you could find a way to relate it to something meaningful, right? So in that example, too, if the person in say trying to remember the phone number, they remember like associating that number with, for example, their date of birth, if it's a coincidence, or the number may be a similar area code to where they live, right? So through those associations, it provides an outlet for persons to make connections, connecting it with other information, and the retention of that information is more likely to happen, right? So the information is more likely to be retained. So when we do that, you're actually engaging in elaborative rehearsal, right? Now, if we were to compare the two, maintenance rehearsal and elaborative rehearsal, we would see that elaborative rehearsal is much more effective, allowing the person to remember and recall the information better than if we were to just use maintenance rehearsal. So essentially, elaborative rehearsal is a more effective way of encoding information. Now, let's go on to the levels of processing theory. So the type of encoding to retrieval proposed by Fergus, Craig and Lockhart is known as the levels of processing theory. Now, according to the levels of processing theory, memory depends on the depth of processing that an item receives. So when we talk about depth of processing, we distinguish between shallow and deep processing. So with shallow processing, this is where we may pay little attention to the meaning of the information. We may focus on the physical features. So for example, like the font has been written, the color, the shapes, the text, right? And this is usually less effective or an less effective way of encoding information. So with shallow processing, it usually involves little attention to meaning, like we mentioned. So like when you're repeating the phone number over and over, so you're not really focusing or attending or making linkages with other or previous knowledge, right? Now, in contrast to shallow processing, there's deep processing, and this involves close attention, focusing on an item's meaning and relating it to something else. So deep processing, just as we talked about elaborative rehearsal, yields better memory retention than shallow processing, right? Because we're creating associations with prior knowledge to the current information, and it usually leads to a better memory. So in an experiment testing memory following different levels of processing, Craig and Tulving presented words to participants and asked them 3 different types of questions. So question 1, they asked a question about the physical features of a word. For example, they had participants see the word bird and ask whether it was printed in capital letters or common letters, right? The second question was about rhyming. For example, persons would have seen the word train and were asked if it rhymes with the word pain. And on the third question, it was a fill in the blank question. So persons would see the word car and ask if it fits in the sentence, he saw a dash car on the street, right? Now, these 3 types of questions were designed to create different levels of processing. So the first one, which would be shallow processing because we looked at the physical features, right? Which would be, is the word bird printed in capital letters? The second, which was rhyming, which was deeper processing, right? And then the third would have been the fill in the blanks. And this was considered the deepest level of processing, right? Now, the results of that study showed, and as we could see on the figure 7.1, deeper processing or the deepest level was associated with better memory, right? Than just looking at the physical characteristics of the letters. Now, one thing we need to note with studies that are looking at memory is we need to be cautious of circular reasoning. So the idea of levels of processing motivated a great deal of research, and it became less popular when it became apparent that it was actually difficult to define exactly what depth of processing is. So if you go back to the previous slide, although the Craig and Tulving would have identified, say, for example, the rhyme as a deep level of processing, but not as deep as the fill in the blanks, there was no objective way to distinguish both as one as being deeper than the other, okay? And we could see how that could be a bit problematic. So in this instance, that is actually an example of circular processing, right? You're defining a procedure as deeper processing in this case, because it results in better memory, and then using that procedure to show that deeper processing results in better memory. So it doesn't really prove anything or support anything. In actuality, what we need to do is we need to find a way to define depth of processing that is independent of a memory test. But such a definition, well, we could see does not exist. Therefore, we consider this to be circular reasoning, right? Because you have to define it first as deep processing and then use it to say, yes, that it results in better memory. All that being said, it does give the idea, all that being said, the idea of shallow and deep processing does give some insight on how we can retain information or be more effective in retaining information. Here we have some other factors that aid in encoding. So one, we could talk about visual imagery, and visual imagery is where we paired associate learning or mental pictures where two items can interact, right? So if we create a visual image of the item and we are trying to also remember or recall the item, we are more likely to retain that information, right? Or encode that information. There's also the self-reference effect. So when we link words or information to ourselves, we are more likely to remember that information or encode that information. That is mostly that occurs because we know ourselves very well. Our idea of ourselves is something that is core in our memory, so we recall aspects of ourselves. So words to anything that we know well, we're more likely to remember, and self being like the main one, right? So words that describe us, like what we like or even what we don't like or what we had for breakfast, once we link it to ourselves, we're more likely to remember. So for example, if persons are asked to recall certain words like cereal, milk, pancake, eggs, ham, toast, right? But when encoding that information, they link it to, okay, these are the breakfast items I do like. So I like cereal, milk, pancakes, and I perhaps don't like eggs, ham, toast bread, right? So when recalling the information, it can link, okay, what are the foods that I liked from that list? And person have an easier time recalling it, as well as just recalling the items that they didn't like, because they linked that information to themselves. The next one is the generation effect. So the generation effect here is where we have persons work out the answer for themselves. So you figure out the answer for yourself. For example, when you have exercises like fill in the blank questions or you engage in self-testing, so like you read information and to test if you encoded that information, you test yourself. It's like you do practice quizzes, for example. Studies would have shown that it actually is easier for students to remember information when there is that fill in the blank questions or self-testing than when they are reading or when they're asked to read the information alone, right? So that's something that you all could keep in mind for when preparing for exams, right? So in conjunction with reading your notes, it's important to test yourself after. Another factor that it aids in encoding is organization, right? It is easier for us to remember information that is organized, right? So a simple method of, if you look at, for example, if you look at your textbook, right, the information is organized by chapters, and which in each chapter there's like topics and subtopics, and they're like headers and like subheadings to differentiate different levels of content and more details of content. Presenting information like that in an organized way, even if it's just visually organized, assist with encoding information. Another way we can think of it in terms of putting things in categories. For example, if you're asked to remember a grocery list of items, so we have, say, fruits like apples, grapes, oranges, mangoes, pineapples, all those things on your grocery list, including other items, for example, broccoli, spinach, pak choy, tomatoes, okay, arguably a fruit, but we could say put tomatoes under vegetables for now. If we were to present that list in a disorganized manner, so mixing each item, it may be harder for you to recall the items on the list as compared to putting it in the categories of a category of fruits, categories of vegetables, and then what other items you have on your list, right? So from this, we could see that when information is organized, it is easier for us to recall. Essentially because we have a retrieval cue, which will be the category being fruits. That retrieval cue will prime our mind or our memory system to retain or to recall the other information in that list. So I could just think about, okay, on my list, what were the fruits? That is my retrieval cue. And then I record the fruits that were on my list, right? Next factor that aids in encoding with words that are related to our survival. So the survival effect in memory refers to a memory advantage for information processed in a survival-related context. So when we relate words to something that is meaningful and important to our survival, we are more likely to remember it. Of course, this would go back to evolution, essentially, right? So our ability to survive was kind of premised on the idea that we could recall what is dangerous to us or what is a threat to our well-being, right? So those of us who would have, our ancestors who would have been able to do that and recall that information, they're more likely to survive than our ancestors who were not able to do so. And last but not least, we have retrieval practice. And retrieval practice, this refers to practicing the retrieval of information by making up and answering practice test questions. And this results in better memory than rereading information. Okay. If we look at retrieval practice, retrieval practice, as we mentioned before, results in a stronger memory trace than rereading material only, right? As compared to being tested on the material. So in this study, participants had to read a passage and then either read a passage, which was the reading group, or recall the passage, which is the test group. And then tested recall after some delay. And from this experiment, we saw that the testing group actually performed better, as we know. And I think I would have mentioned this before, how important it is to not just read, but engage with the material in a way where you practice retrieving that information, because it just leads to you recording the information better. Okay, and now in the next, I'm going to stop this video here, and in the next video, we're going to cover retrieval.